Hello everybody and welcome back to our Math 143 lecture. So last week my video was cut off at around 40 minutes and I was talking about the graph of the function y equals 2 to the x. Okay, so here is a picture of the graph here is a graph of y equals 2 to the x. So you notice that I plotted three x coordinates here. So when you have a function, an exponential function, y equals a to the x, it's pretty easy to look for these 3 points. X equals -1. I'll write them in coordinate form. So the x coordinate is -1 and the y coordinate is 1 over a. 0 and 1, and 1 and 1 and positive a. So if you have a exponential function that is it's in this form, a to the x, doesn't have anything added to it, no coefficient out in front, then you can easily graph it by graphing these 3 points. And in this example, this one is -1, 1/2, 0, 1, and 1, a. Okay, so now, and it's particularly useful when we want to graph functions that look pretty close to a to the x or 2 to the x, to see where these 3 points go. And you'll see what I'm saying here in these next examples. So because we know how to graph 2 to the x, we're going to learn how to graph y equals 2 to the x plus 2, y equals 2 to the x minus 1, y equals -2 to the x. So this is the difference between -2 to the x and this is different. Okay, so we're talking about when a is positive. So when they put a negative out front there, that just means outside of the parentheses. So it's -2 to the x. Okay, and finally, we're going to learn to graph y equals 2 to the -x. All from using this graph here. Okay, so we talked about vertical shifts, horizontal shifts, reflections, vertical stretching or compressing, and horizontal stretching or compressing. So this first one, so I'll number these real quick. 1, 2, 3. So 1, from on Thursday's video, we can graph using a vertical shift. 2. So this one is a horizontal shift because you instead of inputting, it's a horizontal shift of 2 to the x, and this one, number 1, is a vertical shift of 2 to the x. This one's horizontal shift of 2 to the x because instead of x, we're putting in x minus 1. So that's why it's a horizontal shift of 1. Okay, so this one is horizontal shift. This third one is a reflection, and it is a reflection of the x-axis, I believe, because we have a negative out in front here. Reflection Okay, and finally the last one is a reflection about the y-axis. Okay, so based on those rules from the last video, these are examples of the different types of shifts and reflections you can have. Okay, and these are all, so like graph using a vertical shift of y equals 2 to the x. Okay, so let's go ahead and graph these. So we're going to do y equals 2 to the x plus 2. Okay, so I had those coordinates, so I'll write it down here, or over here on the side. The coordinates for y equals 2 to the x. So they were -1 and 1/2, 0 and 1, and 1 and 2. Okay, so now everything gets a vertical shift. That means that your coordinates, you just add the +2 to the y, because this is in the vertical shift form. Okay, so instead, if I write vertical shift here, then it becomes -1. So if I'm adding 2 to 1/2, that's going to be adding 4/2 to 1/2, so 5/2. Okay, and then if I add 2 to 1, this becomes a 3, and then this one becomes a 4. Right, so at -1, I go up, so 1. Okay, so -1, I'm going to be, here's 1, 2, 2.5. Okay. So at 0, I'm at 3. Okay, and at 1, you get back up to 4. So you can kind of, and you can graph a couple extra points if you want to. Like if I put in -2 to x here, it's y equals 2 to the -2, which is 1/4, plus 2. So 1/4 plus 2 is 9/4, so you can just put it right ahead of above 2. And if I plug 2 in here, it's 2 squared, so 4 plus 2, so that goes up to 6. Okay, so the graph ends up having a horizontal asymptote at y equals 2. And this goes on, so there. Right. So these coordinate points are on there, it's just, it doesn't stop. So this is a horizontal asymptote. Okay, so if there's no vertical shift, the horizontal asymptote of this exponential function is just at y equals 0. But in this problem, we had a vertical shift of 2, so our horizontal asymptote moves up 2 as well. Okay, so now we're going to graph the second one. Y equals 2 to the x minus 1. So if we keep in mind that this is a horizontal shift, right? So from the table, So we said y equals a to the x minus c is a horizontal shift to the right c units. Okay, so here it's when you have a vertical shift, it's pretty straightforward, right? If you add on 2, you move up 2. So adding and going up move together. But in this case, it's c. This is a negative number. So if I subtract c, I move to the right c spaces. And if c is, if I have this is saying c is a positive number, and if you have y equals a to the x plus c, that means you move c to the left, because this you're subtracting, and here you're subtracting, and here you're adding. Horizontal shift to the left c units. Okay, so we have an x 2 to the x minus 1. Okay, so we're again going to look for those points here. We have, this is for y equals 2 to the x, so we had negative 1, 5 halves, 0, 1, and 1, 2. So for y equals 2 to the x minus 1, if we have, we're shifting to the right c, so this is going to be 0, 5 halves. Whoops, this is not a 5 halves. This should be a 1 half. I got those two mixed up. Okay, so 0, 1 half, you're just adding c, which in our case is 1, to the x coordinate. So 1, 1, and 2, 2. Okay, so if I plug in 1, I get 2 to the 0 back. So yeah, this is correct. So 2, 2. And if we want to go where the negative 1 goes, we would just plug in x 2 to the negative 1 minus 1. So 2 to the negative 2, that's going to be a fourth. Okay, so it turns out that you get a exponential graph right here, and then y equals 0. Horizontal asymptote of y equals 0. Okay, so you can see that, everything, because we had a 2 to the x minus 1, that original 2 to the x graph right here is just shifted over to the right 1 unit when you graph 2 to the x minus 1. Okay, so we have 2 more to graph here. We've got the graph of y equals negative 2 to the x. So this one is a reflection around the x-axis. Okay, so we're going to take all of our points from the y equals positive 2 to the x, so y equals positive 2 to the x, you have negative 1, 1/2, 0, comma 1, and 1, comma 2. So now I need to reflect it about the x-axis. So that means that all the y values that were positive should be negative if I want to reflect it across the y-axis. So if I had an axis and I had, this is the point x comma y, then if I make the y value negative, it just move it across the y-axis. Okay, so we're going to get, if we have y equals negative 2 to the x, then we get 1 comma negative 1/2, 0 comma negative 1, and 1 comma negative 2. So it's going to be so 0 comma negative 1, okay, negative 1, negative 1/2, and 1, negative 2. So this one is exactly a reflection of about the x-axis of what we had over here. Okay, and then finally, so these are just reference points on the graphs, that are on these new graphs that I'm drawing here. But you can graph any amount of dots and connect them. These, I'm just always using the same three, I'm using the same three starting points. Okay, so like I said, you could have put 2 and you get y equals negative 2 squared. So 2 squared is 4, and then you put a negative on it. So this one, 2 should come down to negative 4. So if the more dots I draw here, the better my graph gets, right? So that it's a little more accurate. Okay, but you can always just use 3. All right, and finally we have the reflection across the y-axis. Okay, so this one is, so now we have negative 1, 1/2. So this is for y equals 2 to the x. Okay, and I have y equals negative 1, 1/2, 0, comma 1, and 1, comma 2. So if I want to do y equals 2 to the negative x, then I should get, I'm going to make all of these negative x values positive. So it's 1, 1/2, 0, comma 1, and negative 1, comma 2. Okay, so if I graph 1 here, it's going to go to 1/2 and 0, 1. 2, negative 2 would go to so these, again, both of these still have the horizontal asymptote at x equals 0, or I'm sorry, y equals 0, because there's no vertical shift. So we saw 4 examples of how to, we saw an example of a vertical shift of a to the x or 2 to the x, a horizontal shift of 2 to the x, a reflection of the x and y axis, and now we're going to do, we're going to try an example of compression and vertical compression and horizontal. All right, so now we're going to try 2 more practice problems. So we're going to do graph y equals 1/3 times 2 to the x. So first we got to see what this is saying. We're not saying that it's not 1/3 times 2 to the x. That's not what we have. It's not 2/3 to the x. It's 2. You first take the 2 to the x and then you multiply by 1/3. Okay. All right. So this is a vertical stretch by it's a vertical stretch. So this is in the form. So this is actually a vertical shrink or compress. Okay. So, okay, here, I'll leave it at this. It's a vertical compress, and if you had y equals 3 times 2 to the x, this one's a vertical stretch. It all depends on whether this number here is between or less than 1 or greater than 1. So it's going to be a positive number. So if we write y equals c times 2 to the x, c times a to the x, let's be a little more general. C times a to the x. Then it's a vertical compress if it's a vertical compression if this number c is in between 0 and 1, and it's a stretch if c is greater than 1. So here our c value is 1/3, and here our c value is 3. So that's definitely, 3 greater than 1, 0 less than 1/3, less than 1. So this is just our example that we're using. Okay, so you might as well. So why are we only using negative numbers here? Because the negative numbers case is taken care of in the reflection around the x-axis. So you could have like any combination of these reflections, shifts, and stretching or compressing. But we're just kind of doing examples of one at a time, and then I'll do an example of doing more than one. Okay, so if we go ahead and graph this one, so this is going to make your pair is going to go from x comma y to x comma c times y. Okay, so we had -1, 1/2, 0 comma 1, and 1 comma 2. So now it's going to be -1. And so for this first example, for a vertical, we're going to graph just this top one here. So for y equals 1/3 times 2 to the x, we just multiply 1/2 by 1/3. So this is now 1/6. And this one is 1/3. And this one is 1 comma 2/3. So now we can draw that. Okay, so we have -1, 1, 2, -2. So 1, 2, 3. So down here we've got a sixth, and here we would have a 12th, so even smaller. 0, 1/3, and 1, 2/3. And then we'd go up to 4/3 at 2. So it's still exponential, it's just growing smaller, or slow. Its growth is slower. So that's an example of vertical compressing and stretching. So that one was a compression, but if you would have done y equals 3 times 2 to the x, instead of multiplying by 1/3 in each of these y values, we would be multiplying by 3, and this graph would be a lot bigger. Okay, so finally, let's talk about one more thing. We can still have horizontal. That was a vertical stretch and compression. Now we have horizontal stretch / compression. Okay, so this one is when you have y equals a times c to the x. So this one is going to make your, so the y, yeah, so here we would have y equals x over c times y, and so that goes with this one if y equals a to the x. So it's saying your xy values from y equals a to the x will become x over c comma y values for y equals a to the cx.